Greetings, true believers. My name is CT Leffler, and welcome to this episode of Pump and Motor Dialogue. On today's show, I've got Kyle Merrill. Kyle is the R&D Engineering Manager on the Greenville side of the Pump and Motor Division, and he's going to be telling us all about the new improvements that have been made to the BG and BH series of brake motors. Plus, as always, we dive into a little bit more about how he came to be an employee here at Parker, what he does in his free time. We put him through the Q&A round, so be prepared to learn all about his preferences of chocolate, music, and what he does with that darn elephant. And as always, we learn a whole lot more about the product lines here at the Pump and Motor Division, applications, and all sorts of improvements that are being made. So with that being said, let's dive into this episode with me and Kyle Merrill here on Pump and Motor Dialogue. All right. Well, Kyle, I appreciate you coming on the show today. Have you ever listened to the show before?
I have not.
You haven't? Okay.
You'll have to send me the link to it.
Well, hey, maybe you'll listen to this one.
I will.
Okay. Well, that's okay. You're not the first person to come on the show that hasn't listened to the show. It's going to make our Q&A session a little more fun, because if you had listened to it, then you would know the questions already. But we'll start off like we always do. Kyle, can you just tell me a little bit about yourself?
Yeah, I've worked with Parker Hannifin for about 20 years. That whole career is in new product development. I love bringing products to the market, and I've got a PhD with an emphasis in fluid power from Purdue University, and just love fluid power and bringing products to market. So
okay.
I love where I'm at.
So if I put Dr. Kyle in the episode title, like that's technically correct. Yes?
It is, but I prefer Kyle. So.
Okay. All right. Fair enough. So new product development. I assume that means that you've been working on these products for 20 years. Can you just give me like a high level list of some of the products that you've been a part of and ushering out over the last 20 years?
Yeah. Within Parker, I've been with 3 different divisions.
Okay.
So I started out my career in the pump division up in Ohio.
Okay.
And so that's where the axial piston pumps were made. And I got to work on port plate design to make them quieter. There was a pump that we made that had electronic control on it, and so that was a really fun project that I worked on a while, and with my master's degree kind of in controls, got to work on the hydromechanical controls of the pumps and the electrical controls of the pumps, so bringing those types of products to the market at Marysville, and then I got to spin. Parker had a startup division that did hydraulic hybrids, where they're taking the hybrid technology in hydraulic world, and that was a fun division to work with. A lot of great people there. And then about 8 years ago, I got to come down here to Tennessee and at the pump motor division and working on hydraulic transmissions that go on turf equipment, and then also the hydraulic motors and just all the kind of the changes to the product to make them better, more efficient, and just better for our customers. So.
Okay, so you've been in the hydraulic side of things, but you've been to a few places here around Parker. Are you a native of Ohio, or did that just happen to be where you landed first?
I'm not. I grew up in northern Utah and wanted to get an advanced degree, so went out to Purdue University in Indiana.
Oh, very nice.
And then that got me close to Ohio, where I had my first job there in Marysville, Ohio.
Okay, so when you were getting your doctorate, what was your thesis on?
It was a digital pump motor. So the best way I like to describe it is similar to cars, where they turn off cylinders for efficiency.
Oh, yeah.
So each piston pump has on-off valves at each piston pump, so you can just leave the inlet valve open, so that piston is always idling instead of producing high-pressure fluid. So then you don't get the leakage and the losses due to that. So it's kind of similar to a car engine that turns off pistons. You turn off pistons to get variable flow in a digital pump motor. So.
Okay, no, that's really interesting. Have you seen that? Like, is that the way the industry kind of has started heading, or is that a little more work needs to be done there?
Yes, of both.
Okay.
There is a company out of Scotland that one of Parker's competitors is looking into that technology, and so they're trying to give it a go, and so that was pretty exciting. And so I kind of see what they're doing and see is it going to make it to the market or not. But yeah, it was a really fun PhD thesis. I'd been with Parker about 6.5 years when an email came across my inbox to go back to school. And so I'm like, I love learning. I love R&D. I just so it was a good break from working, and now I'm back with Parker. So
very interesting. What is it about hydraulics that you really enjoy?
Mechanical engineering is just solving problems, but now you have mechanical forces, hydraulic forces,
right?
And then when you add the electrohydraulic, there's 3 different domains that you have to master to bring them all together in electrohydraulic, mechanical, and so just the challenge of understanding and mastering all 3 of those domains, the mechanical forces, the hydraulic forces, and then the electrical actuation of those. So it's been a great thing.
Yeah, and I mean, they're ever developing sections of mechanical engineering, so it's never like you never know it all. There's always something new on the horizon that you can dive into and learn, or potentially even be on the horizon of developing yourself.
Yep.
Well, we're going to get to our brake motors here in a little bit. We've made some changes to those that you were a big part of, and I do want to talk about that. But first, can you tell me a little bit more about what you do outside of Parker when you're not here? You know, when you're out in Tennessee, wherever you live. What do you like to do?
Yep. No, yeah, I live here in the Greenville, Tennessee area,
Okay.
and moved here from Ohio. And growing up in northern Utah, I loved hiking. Not a whole lot of mountains in central Ohio, so I did miss the mountains. And so it's been a good move for me and the family, and we love hiking to the waterfalls here in the local areas. Beautiful hikes and whether kayaking or canoeing on the lakes here, and so I just love being in the outdoors, camping with the family.
Okay.
So.
Well, this is a great place to do it. I mean, just on my way here from Charlotte, you drive through the mountains, you're driving alongside rivers and creeks, and I mean, it's lovely terrain, landscape. What's the right word I'm looking for? Forests. It's just a lovely area of the country. So if that's what you're into, this is absolutely a great place to be.
It is.
Okay. Well, let's talk about brake motors a little bit. Let's just go high level first. What's the difference between an ordinary torque motor, like a TG, and its brake motor counterpart, the BG?
Okay. Again, the BG brake motor was developed about 20 years ago here in Greenville, and the good thing about it is it's an integral brake motor that's not exposed to the elements.
Okay, so it's inside the pump.
So it's inside the motor.
Or the motor.
Yep. And so it's a spring-applied hydraulic release.
Okay.
So if you don't apply hydraulic pressure to release the brake, the springs will engage the brake and hold the output shaft from moving.
Okay.
And so a lot of wheel drive applications, whether it's a large turf equipment, whether it's a large chipper shredders or stump grinders, the wheel drive on that they need to keep the machine from moving, a static brake. And it's really advantageous to those customers that maybe had a lot of mechanical linkages to some sort of brake. All that could get removed, and you have a hydraulic line, provide the hydraulic pressure and release the brake, and you can move the machine, whether you drive or move it to a different location before you set the brake again, and just remove that hydraulic pressure, and the spring applies the brake. And like I said, it's all internal, so rain or anything like that's not going to affect the brake performance. So.
Okay, so it removes individual components from a hydraulic system by having all of the braking inside. I don't think this is a brake motor. It's just
that's just a kind of a standard motor that we apply the brake package to.
Yeah, but everything is inside of this package. And you mentioned that there's a separate hydraulic hose going in there just for the brake. So does that mean there's 2 hydraulic lines going to it, one for the actual driving and one for the brake section?
So there would be 3.
Okay.
You'd have the inlet. So another advantage to the Parker motors is you only need 2 lines to move the motor.
Okay.
Other motors need a K-string.
Okay.
Where we have a shaft seal that can handle high pressure, so you have just the A and B lines, so the inlet to the motor and the outlet. And then so there's a third port that you just plumb in hydraulic pressure.
Gotcha.
And it can be a charge pressure or it could be full system pressure up to 3,000 psi.
Okay, so
you have 3 ports that you have to plumb up.
Okay, so it can be a separately managed application system.
Yep.
Gotcha. Okay. So the brake motor is not necessarily new, but I understand that you've made some new changes to the brake motors here at Parker.
Yep.
Can you go into a little bit about what drove those changes?
Yeah, we had a few customers as they developed their applications were interested in speed control of the machine. And so some of our hydraulic motors have the ability to get a speed sensor with the hydraulic motor, but the brake motor did not. And so that was a key driving element to the changes. And we went through 3 or 4 different scenarios of how to get speed off the output shaft of the brake motor. And the one that ended up winning the idea was to pick it up off the output shaft, but the problem was the springs that apply the brakes were in the way of the speed sensor. And so the old product before the change was made had 8 spring pockets. And so we needed at least one of those pockets to plumb in the speed sensor.
Okay.
And so that created some other changes. And so since we were changing the casting, it's 20 years old, let's use all the FEA analysis tools that have come along a long way, and let's get some of the weight out of it. So we were able to get about 5 pounds out of the weight.
That's a lot.
So it's huge weight reduction. Make it lighter for our assembly team that's putting the motor together, and also vehicles. Weight is important on moving vehicles too. And so we removed 2 of those spring pockets. So now you don't have as much spring force holding the torque. So because of that, we had the BG brake motor had 5 friction discs sets, and the BH had 6.
Okay.
So removing springs, you now need more friction. And so that was another thing, since we were changing operations, there's a lot of complexity. As you look at the old catalog, the BG had 5 sets, and it could have either 4, 6, or 8 springs, but you have 8 pockets. So that's kind of a little complexity for the assembly team. The BH had 6 sets instead of 5, and could have 4, 6, or 8 springs.
Okay.
So very complex assembly options. And so one thing is we reduce that complexity. So the new BG/BH both have 7 sets of discs.
Oh, that's much easier.
Much easier.
Okay.
And instead of 8 pockets, they have 6. So we now have room for the speed sensor. And those 6 pockets always have 6 springs. And so the old brake motors, you could the standard BG is 12,000 inch-pounds of torque holding, but some customers wanted 9. Some customers wanted 16. The old BH brake motor standard torque holding was 16,000, but some wanted 12, some wanted 9.
Is that why you would use different numbers of springs?
Exactly.
Okay.
Exactly. Different number of springs would get that different torque holding. And so now, since they both have 7 sets, reduce that complexity, we added another spring. We used to have 2 different springs, so now we have 3 different springs.
Okay.
And so that makes sense. 7 sets, 1 spring relates to 9,000, 1 spring relates to 12,000 inch-pounds, and 1 spring relates to 16. And so we color code those, so it's very easy for assembly to whether it's a BG or BH, it gets 7 sets of discs, and depending on what torque holding the customer wants, it gets the gray, gold, or green springs.
Okay, so the gray, gold, and green springs, you said there's 6 in the BH, 5 in the BG. Is that right?
So that was the old.
That's the old
complicated way.
That's
now it's simple, 7 sets.
7 sets
in both of them.
In both of them,
and then the spring color determines what torque holding.
Okay, and those different springs just have different spring force.
Exactly.
Applied to them. Okay, well that's quite an it's a really impressive design. I mean, it's really the only way I can say it. I mean, it sounds like we've gone from a fairly complex brake motor, and then it's like, well, we have to take components out of it, and how are we going to keep all of the same properties of it while getting rid of things? And then you've also been able to take that weight out. And then at the speed sensor as well. So does that mean the speed sensor comes standard with BG and BH motors now?
It's an option.
It's an option, okay.
Obviously, if a customer doesn't need it, they wouldn't want to pay for it. And so we just have the space there that we can machine the speed sensor port in and add it for the customer. And it's like our other speed sensors. We machine in the output shaft the targets for the speed sensor. And so there would be 30 pulses per revolution on the speed sensor. And again, for those wheel drive applications where that's important,
Yeah.
or other applications where they need to maybe count the revolutions that the motor is providing, and that technology is now available. So.
Okay. So the new style of BG and BH, is it a drop-in replacement for the old style? Can someone just take out their old BG and put in one of the new style?
It is. That was one thing, because we have a lot of customers out there that are using the BGBH, and so that was one of the requirements that we kept, is that fit, form, and function needed to be the same. So the hydraulic ports, to where it can be either front mounted or rear mounted, all those dimensions needed to stay the same. The size, taken weight out, maybe got a little smaller, so it wasn't bigger, so it still fit in current applications. And they wouldn't need to worry about redesigning their machine, because we made some changes. And so that was important for our customers, that the new design works the same and fits the same as the old ones.
Okay. And so, all right, so you took weight out, you changed the springs, you changed the friction plates to reduce complexity. You've added the speed sensor. It's drop in, drop out. Is there anything we're missing here about this new design? I mean, if there's not, that's fine. You guys have done quite a bit here.
Yeah, no, again, the key thing is it's a integral brake, so a hydraulic release, where some of the applications out there have mechanical linkages to get to a drum type brake. And so this spring applied hydraulic release can remove some of the complexity for the customer. It's protected from the elements, so there's no dirt, debris, or grass or water getting in there to affect the brake holding, and just a nice design that we wanted to make the added addition of the speed sensor, and make it a little lighter, and make it a little less complex to assemble. And for those that ever want to maybe rework it in the field, it's like, okay, do I put 4, 6, or 8 springs in 8 pockets? And so now it's very simple. There's 6 pockets and 6 springs.
Perfect. So you mentioned that some applications may use a regular torque motor, a non-brake torque motor, and a drum brake. Are there some advantages to using a spring brake over a drum brake, or vice versa?
I guess it depends on the complexity of the machine. And does it have other hydraulic functions, so you have that hydraulic release capability? Yeah, I guess each application, that's why we have both. We have drum brakes and we have hydraulic release brakes. So it depends on the application, on which is the better fits.
Right. And here we are at the midpoint of the show. If you'd like to learn more about the Pump and Motor Division, please visit our website at parker.com/PMD. There you can learn all about our products, industries, and solutions, as well as finding out where you can buy products that you see and hear about here on Pump and Motor Dialogue. Again, that's parker.com/PMD. Now let's get back to the show.
Sounds good. Another advantage is, compared to the drum brake, is that there's no linkage adjustments required. With it being a hydraulic release brake, you just provide the hydraulic pressure, it releases the brake, you remove the hydraulic pressure, and the springs apply the brake. And so that's a nice advantage. Another advantage of the internal brake is it's on the output shaft. So some of our competitors take advantage of the torque of the hydraulic motor and brake past internal components. So if those internal components ever fail, then you don't have the braking capability. And so it's a robust design that brakes at the shaft that's attached to whatever's moving in the application, whether it's a wheel or anything else. So.
Okay, so there's a little bit of fail-safe built into it, just by where it's applied within the system.
Yep.
Okay. Well, I do know there is one pretty cool thing about this design. You guys won the Golden Mousetrap Award that Parker gives out every year.
Yes.
And I have to talk about it because it's right behind us.
Okay.
We didn't know it was back there until Kyle got in the room before we started shooting. But this... Oh, that is just pure resin. Wow, that's heavy. The Mousetrap Award given out to some of the best designs from around the company. Now, I don't know if this is just for the Motion Systems Group or if this is for Parker in general, but, I mean, either way, congratulations.
Thank
you. Know,
you.
I don't know how else to say it.
No.
Did you guys know you were in the running for this when?
We all the divisions pick new product developments that they want to present to the group to get voted on, and so this is one of the projects that was pretty successful. Simple by Design is taking design principles, again simple, taking that complexity out of the assembly, taking weight out of the castings to make it lighter, better ergonomics, also less casting material and things like that, and then design for reuse. There was a Parker division, Parker Chelsea, that makes gearboxes, clutches. So reaching out to them, what vendor do you use for your clutch plates, and going to that supplier to get some really good disc clutch type plates, and just kind of utilizing what's already out there, so you're not reinventing the wheel.
Yeah.
And so yeah, all those simple by design principles that Parker wanted us to implement, we did in this project, and they rewarded us with a nice award for
There you go.
for doing a good job on a product refresh. So
Nice. All right. Well, hey, that's awesome.
thank you.
All right. So that's really all the questions I have for you about the new designs around the BGBH. Is there anything you'd like to add before we jump into this Q&A section?
You had some great questions, and I think we covered the
All right,
product,
cool.
so.
All right, so are you ready for the Q&A section?
I hope so.
Okay. We're going to find out something about you, Kyle. There's nothing crazy on here. You know, you're not going to, like, hurt any relationship. Well, you might, but not in terrible, reprehensible ways. People might just have questions about your answers, and I may have them too. So I'll ask the question, we could talk about it, discuss a little bit, maybe I have a follow-up, maybe you want to ask me something, you know, we'll just we'll see where it goes.
Okay.
All right. So first question I have here is, what is the last song that you listened to?
Oh wow. My kids like to play the piano, so I'm trying to remember what the last song they played.
Okay. So you don't listen to the radio on the way into work, or a podcast guy?
More talk.
Okay, more talk,
radio,
right?
podcast. So, my daughter's better at naming the songs than I am. I can't remember.
Something your daughter played on the piano.
Yes.
We'll go with that.
Yep. That was the last song I listened to.
Okay. What was your favorite childhood TV show?
Favorite childhood TV show? Probably G.I. Joe.
G.I. Joe. All right. No, that's a good answer. That's a good answer. All right. Now this one's a bit more of a thinker, so you can take a second if you need to. If you received an elephant and you had to keep it, can't get rid of it, can't donate it, can't sell it, can't do other things with it, had to keep it, what would you do with it?
Ooh, I'd probably put it in the backyard.
There you go.
We love Tennessee. We were able to get 10 acres, and so we've got chickens and sheep, and so I guess we'd start a zoo and
Might
just
as well have an elephant.
add the elephant and,
Yeah.
and keep going. So.
Nice. Now we're not cops here. What is the fastest you've ever driven?
Me, myself, probably 80 or 85.
80 or 85.
Yeah,
Keeping it
pretty safe.
pretty safe. But you said you yourself, have you been in the car?
Yes.
While it was going
So
faster?
strange story.
Okay.
I'm glad I'm still alive.
We love strange stories here. So.
Senior year in high school.
Okay.
My English teacher was retiring.
Uh-huh.
So she had senioritis worse than we did.
Oh, yeah.
So
Senior
was
citizenitis.
test driving, I don't even know if she'd bought it yet, but test driving a yellow sports car.
Okay.
For some reason, she gave the keys to us seniors, and I'm in the car while a friend of mine's driving in the back roads. I grew up in a town of 2,000, so kind of country.
Okay.
And I think he hit 110, and I'm thinking to myself, I have no control of this situation.
Nope.
I am not behind the wheel. I'm at the mercy of this teenage boy.
And she sounds like
and
she
we
really-
survived. And,
That's good.
And I'm glad, because she would have probably got in trouble. So that was the fastest I've been in a car, and
Okay.
I was not in control, and so I like being in control. So.
Okay. Man, it sounds like she just didn't care.
Yeah.
She
She
just passed
was-
off the keys during a test drive?
Yeah.
Whew. Wow. All right. What is your favorite carnival food?
Ooh, probably the elephant ears, the scones with the powdered sugar. That's pretty. That's
no,
pretty good.
that's a good answer. Dark milk or white chocolate?
Milk.
Milk.
Yeah, I don't like dark chocolate, but milk chocolate. Yeah.
Okay. So you're traveling on the road by yourself. Maybe it's for work, visiting a customer, something like that. You're in a hotel room by yourself. What temperature are you setting that thermostat to?
Probably 73.
73?
Yeah.
Wow, that's pretty high.
Yeah.
It's pretty toasty. What is it at home?
In the summer, 78.
Okay.
In the winter, 72.
72. All right. So keeping it toast. Hey, you're saving that energy. I'll give you that. Yeah. All right. Name a 4-letter word that starts with B.
Ball.
Ball. Always a classic. What is your favorite color and why?
I'm thinking of Monty Python. Blue, probably.
Blue. Okay. Why is it blue?
I don't know. Just always liked blue.
Is it a particular blue that you're more...
Undergrad was navy blue colors.
Okay, yeah.
Utah State University, so probably navy, more the darker blue.
Okay, yeah. It looks like you have bluish
I do have blue eyes.
Yeah, we're in the blue eye gang.
Yeah.
There we go. And, I mean, that always you wear some blue, your eyes are popping.
There you go.
Yeah. If you could instantly... This is the last question, by the way. You did a great job. If you could instantly become an expert in one skill, what would it be and why?
Ooh.
Now, there's a couple ways to go here. You can either pick something that you have no skill in and that you'd like to do, or we've had people pick things that they're kind of good at. Maybe they've been working on it. Maybe they fell out with it, that they would like to pick back up and be just immediately great at.
I mean, non-work related, if we just go fun skills.
Yeah. Oh, fun skills.
Yeah, I would say juggling. I can do three balls,
Okay.
But when you go to these places and they're doing knives and for whatever, all sorts of juggling, that's pretty cool. And
That
so
is pretty
I like
cool.
the hand-eye coordination, but I'm by no means an expert, and so
Yeah.
I think I'd pick juggling.
I started learning to juggle this year.
There you go.
Yeah, I was like, I'm gonna figure it out, and I got 3 pretty quick. I was kind of surprised how quickly I got 3.
Yeah.
Now, some days I can keep it going for a little while until I realize that I have 3 going for a little while, and then I mess up. And some days I can't hardly get it going at all. But no, juggling is a very good one. I can get behind that one.
There you go.
All right. So I have one question that I ask everyone at the end of the show. But before I do, is there anything you'd like to say? Can be about brake motors, can be about Parker, can be about you, whatever you want, to just send out to the podcast audience before we jump off.
No, I'm good. It's again fun to get this opportunity. I'll have to check it out now that I know I'm going to be out there, and I'll follow you and the ones that you do. It's pretty neat. Parker's a great company. It's been the company I've worked for my whole career, and I've loved it. So.
All right, cool. Well, final question, same one we always ask everyone. Give me one personal goal and one professional goal that you have for yourself right now. Is it juggling?
Personal goal? No. As I'm getting older, I want to get back into running. I played soccer growing up and never really got the love of running, but I think I need to since I don't have a soccer team or whatnot, I need to get back into running. So that's a personal goal.
Okay.
Professional goal is just never stop learning.
Never stop. That's a good one.
Always be learning, growing, developing. About 2 years ago, I moved into the R&D Engineering Manager role, and I'm loving that, being a people leader and helping the other engineers succeed. And so, growing my own skill set, but also helping others succeed is a good professional goal that I have. So.
Okay. All right. Well, hey, Kyle, this was fantastic. I appreciate you being on the show. Did a great job.
Thank you.
From my perspective. Yeah, man. Thank you very much.
Thank you.
Have a good one.
You too.
All right.
Bye.
And there you have it, folks. My interview with Kyle Merrill about the improvements that were made to the BG and BH series of brake motors. The Mousetrap Award and I would like to thank you for listening to this episode. One little correction, this is not the Golden Mousetrap Award, but this is the Mousetrap Award for the Motion Systems Group. Either way, big props to our engineering department. We love what you guys are doing out there. If you'd like to learn more about the show, have questions about the show, or potentially would like to be on the show, shoot me an email at pumpmotor@parker.com. That's pumpmotor@parker.com. We're always looking for requests and would love to have you on the show to talk about whatever it is that you're passionate about within the world of hydraulics. If you enjoy the show, be sure to like and subscribe anywhere podcasts can be downloaded, as well as on Parker's product and support channel on YouTube. With all that being said, we'll sign off like we always do. My name is CT Leffler. This is the Mousetrap Award. This has been Pump and Motor Dialogue, and Beetlejuice, Beetlejuice, Beetlejuice. Let's get out of here. Have a good one.